Hello everyone, welcome back to my channel. So this is the continuation part of a chapter called higher order derivative. In the previous class we have discussed about the Leibniz theorem, and also we have proved some questions, or which we have discussed some questions based on that topic. So this is the continuation part of Leibniz theorem. The question is given that if y is equals to tan inverse x, so here the y value is given as tan inverse of x, then it is said that to prove 1 plus x square y2 plus 2x y1 is equals to 0. So we have to prove this value, and also we have to prove 1 plus x square yn plus 2 plus n plus 1 into 2x yn plus 1 plus n into n minus 1 yn is equals to 0. So this is what we have to prove. So first, with the help of y is equals to tan inverse, we will prove the first equation which is given to prove. Then with the help of this equation, by applying the Leibniz rule, we will solve the other equation to get the value. So let's start the video. So here it is given y is equals to tan inverse, which is already given in the question, that y is equals to tan inverse of x. So we will do the derivative for this step, for this equation, particular given equation. So with respect to x, which we have done, and we know the notation for dy by dx is y1, and similarly d square, that means if we do the derivative for y1, you will get the value as y2 and so on. So in that manner, dy by dx is equals to y1. That means the notation for dy by dx will be written as y1, and the derivative of tan inverse x value is 1 by 1 plus x square. Now if you see here, the denominator value, which is 1 plus x square, will multiply to the left hand side, and we can get the value as y1 into 1 plus x square is equals to 1. So consider this as equation 1. So what we got the value here is y1 into 1 plus x square, which is equals to 1. Now again we will do the differentiation to get the value which is given here, 1 plus x square into y2 plus 2x y1 is equals to 0. To get that value, what we have to do is, we have to do the differentiation, that means with respect to x, to get the value. So if you see here, it is in the form of y is nothing but our u value, and 1 plus x will be act as a v value. So if you see here, it is in the form of the product rule. The derivative of uv is equals to u derivative of v, then plus v derivative of u. So this is the formula which we have used here. By using that formula, I have written y1 derivative of v, that means 1 plus x square plus 1 plus x square derivative of y1 is equals to 0. Now the derivative, so y1 and then the derivative of 1 plus x square. So here one value is a constant value, so 0, and the derivative of x square will be 2x plus 1 plus x square. If you see here the derivative of y1, then as I have taught here, the derivative of y1 will be written as y2, and similarly the derivative of y2 will be written as y3, and so on. In the same case, here I have written the derivative of y1 as y2, which is equals to 0. Now rearrange this sentence, that means the equation. I get the value as 1 plus x square into y2 plus 2x y1 is equals to 0. So this is our second equation. We got the proof here. If you see here, 1 plus x square y2 plus 2x y1. So this is what we got the value. Now by using this second equation, we have to prove one more value by using the Leibniz theorem. Now apply the Leibniz theorem to this equation. On applying, so this is our first part of the function. That means overall the equation is given, so consider this as a first part, and this will be our second part of the given equation. So for this I can write, if you see here, 1 plus x square, so y2 will be our recurrence function. That means you will get the repeated values. That means the value repeats. And then 1 plus x square will act as non-recurrence function. Okay. So as I have taken here dn by dxn of y2 1 plus x square. For this d nc0 dn by dxn, y2 will be our recurrence function. So y2 1 plus x square plus nc0. So up to how many steps we will take this one? Until we get the recurrence function value as 0. That means if you see here, the derivative of this function, for the first derivative we get 2x, and for the second derivative we get the value as 2. So up to 2 steps, that means 1 and again up to 2. So nc1 d to the power n minus 1 by dxn minus 1 y2, and the derivative of this function, that means a non-recurring function's derivative for the first time, and nc2 d to the power n minus 2 by dx n minus 2 y2. So second term derivative of the 1 plus x square. So this is what we have written for the first part, and similarly we have to write for the second part. So here the recurrence function will be y1 and the non-recurrence function will be 2x. So if you see the derivative for 2x, so when we do the derivative, we get the value here 2. So only once we have to write. That means NC1. So NC0 will be written as usual. And then one more step has to be written, that is NC1. So here plus NC0 d to the power of n by dx to the power of n y1 into 2x plus NC1 d to the power n minus 1 by dx to the power n minus 1 y1, and then derivative of 2x. Now substitute the values. The value of nc0 is 1, and if you see here d to the power of n by dxn y2. So this is what it is given, the d to the power n by dx to the power of n y2. If you see here y2, the power is given n, so plus n. So we can write yn plus 2. Okay, now 1 plus x square, and we know nc1 value is n, and here it is given that d to the power n minus 1 dxn minus 1, and here it is given 2. So now for this I can write this value as y2 plus the power value is n minus 1. Now on solving, if you see 2 minus 1 will be 1, and here it is n is present, so y is equals to n plus 1. So this is what we got here, and then I have written the value. Then if you see the derivative for 1 plus x square, you will get 2x, and the value for nc2, the value will be n into n minus 1 by 2 factorial. The same procedure here we have to follow. Here it is given derivative to the power n minus 2, here also dx to the power n minus 2, and here we have 2. So if it is given like this, the two positive and negative value will get cancelled out, and the remaining will be yn, and then the second term derivative of 1 plus x square will be 2. And now the second part which is there, it is given nc0 value is 1. If you see d to the power of n by dx to the power of n y1. y1 means here 1 plus n. So will be written as yn plus 1 2x plus nc1 value will be n, and here y1 and its power is plus n minus 1. So these two values will get cancel it out, and the remaining will be yn. Here the derivative is 2, which is equals to 0. Now let me write this one as, see here 1 plus x square yn plus 2 plus 2x n yn plus 1. Then here 2 factorial and 2 will get cancelled out, since 2 factorial, which is nothing but 2 into 1, which is equals to 2. So the remaining will be, on multiplying this value, I got the value as n square minus n yn plus, here the value is given 2x yn plus 1. Then again 2 into n yn is equals to 0. Now in the next step, it is taken as See here 2x n y n, and also here we have 2x y n plus 1. So here the common terms is nothing but 2x yn, and here also we have 2x yn. So on taking common, I can write the step here as 2x yn plus 1 as common. Here n is present and here no value is present, so n plus 1, and then multiply this yn to both the values, then it will be written as n square yn minus n yn plus 2n yn is equals to 0. In the next step, it is given that here the value will get subtracted, that means minus n yn and then plus 2n yn, that is n yn. So this is what I have written. Then here in the last step, if you see 1 plus x square yn plus 2 plus 2x yn plus 1 n plus 1 plus here the common terms has taken, that means yn is a common term, so as I have written n into n plus 1, then yn is equals to 0. So this is what it is given to prove by using the first equation. So we got the value. Now let's go for the second question. It is given if y is equals to e to the power of m cos inverse x. So here the y value is already given. Then it is said to prove this equation. That means 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1 minus n square plus m square into yn is equals to 0. So we have to prove this equation. So now consider the given equation y is equals to e to the power of m cos inverse of x. So it is in the power form, e to the power m cos inverse x. Okay, now we will do the derivative for the given equation. On getting derivated that equation, you will get the answer as y1. So derivative of y will be y1 is equals to the derivative of, so if you see here, the derivative of e to the power of x will be e to the power of x only. So the value m cos inverse x is considered as x. So e to the power of m cos inverse of x. Again, now here we will follow the chain rule. So d by dx of m cos inverse of x. So here m is a constant value. So this is our constant. So the constant value, then cos inverse x, derivative of cos inverse x value is equals to 1 minus root over 1 minus x square. So this is what I have written, and then on multiplying the values, see here the denominator value which is present, root over 1 minus x square, will get multiplied to the left hand side, then it will be written as y1 root over 1 minus x square is equals to minus m e to the power of m cos inverse of x. Now as we have taken e to the power of m cos inverse as y, here also we got the value e to the power of m cos inverse x as y. So I have taken this value as y, which we have already in the question. So now to cancel out the root value, just apply squaring both sides. So if you do squaring both sides, that means in the RHS side as well as LHS side, you will get y1 whole square root over 1 minus x square whole square is equals to minus m whole square y whole square. Okay, now this will be our first equation. Now using this equation, we will do the differentiation and we will get the value. See here, this will be our y1 whole square 1 minus x square. After applying square, here the value gets cancelled out and the remaining will get derivated. So derivative of y1 whole square 1 minus x square is equals to, so minus m whole square will be m square only. So m square, it is a constant value, derivative of y whole square. Now see here, by following the here we will follow the product rule. Here y1 whole square is our u value and this will be our v value. So u derivative of v plus v derivative of u. This is what we have written by using the product rule. Then which is equals to m square derivative of y whole square. Then solve this one. Derivative of 1 minus x square will be minus 2x. And then derivative of, see here, the derivative of y1 whole square. So anything to the power of x square derivative is nothing but 2x. Right? So similarly here, derivative of y1 whole square will be written as 2y1. Again, now follow the chain rule. So if you see the derivative of y1, as I have told you in the previous question, if you see here, when we do the derivative of the y1, we get y3. Similarly, here also we will get, when we do the derivative for y1, we get the value as y2. So this is what I have written here. Then m square derivative of y square. So this is also follows the same condition. So derivative of y whole square. So 2y and derivative of y will be y1. So 2y into y1. Then again, now multiplying the values and solving the derivative, we got this equation. Now we will arrange the values. That means 1 minus x square 2y1 y2 minus 2x y1 whole square is equals to 2 m square y into y1. Now if you see here, let me cancel the 2y1 value. So write it here as divide 2y1. So when we divide the 2y1, here the 2y1 value will cancel out here in this form, and here also the 2y1 will cancel out, and the remaining will be 1 minus x square y2 minus x y1 is equals to m square y. So this will be our second equation. Now in this second equation, we will apply the Leibniz theorem. So as usual, this will be our first value and consider this as a second value. In the first value, y2 is our recurrence function, 1 minus x square is our non-recurrence function. When we do the derivative of the non-recurrence function, we get the value. For the first derivative we get minus 2x, and in the second derivative we get the value as 2. So up to nc2 we will take the value up to nc2. So on applying the Leibniz theorem in the first part, will be written as nc0 d to the power of n by dx and y2. Okay, so because this is our non-recurrence function and this is our non-recurrence function, plus nc1 d to the power n minus 1 by dx to the power n minus 1 y2, and the derivative of 1 minus x square will be written here. And same, by following the same steps, nc2 d to the power n minus 2 by dx n minus 2 y2, and the derivative for the second time of 1 minus x square will be written as like this, and the same steps has to be followed for the xy also, which is equals to m square. Since here m square is a constant value, and we will take only nc0 because it is a recurrence function, there is no value, there is no non-recurrence function. Okay, now we will substitute the value. nc0 value is n, and if you see here, as I have told you, y2 and the power is n, so plus n, which is also written as yn plus 2. Okay, so 1 minus x square, and nc1 value is n, and for this y2 the power is in the form of n minus 1, which is equals to n plus 1. Then the derivative of the 1 minus x square will be minus 2x plus, and the value of nc2 is n into n minus 1 by 2 factorial, and the derivative for y2, so here the power is in the form of n minus 2, which is equals to yn, and then the derivative of this function d square, means second time derivative of 1 minus x square will be minus 2. And the same procedure has to be followed for all the functions, then in the next step if you see the factorial value of this function, and here minus 2 will get cancelled out, and it is written by arranging the equation like 1 minus x square y n plus 2, then here minus 2x n y n plus 1. So here minus will get multiplied, so minus n into n minus 1 y n. Again here minus will multiply to the, yes, minus will multiply here, so here we will get x y n plus 1. Again here we will multiply the minus, this will be written as minus n y n, which is equals to m square y n. Now in this step what it is written as 1 minus x square y n plus 2 minus 2x n y n minus, see here we have x y n plus 1, here also we have x y n plus 1. So the value here we have to take common is y n plus 1. Okay, so here I have taken that y n plus 1 as common, then the remaining will be in the bracket. That means I have written already here the equation x y n plus 1 2n plus 1. Then on multiplying the values n square, then here on multiplying you will get minus n y n. So minus n y n is equals to m square y n. Now after taking the common, I just removed the value, that means here the positive and negative terms will get cancelled out. Here the yn is a common term, so yn has taken common, then n square minus m square is equals to 0. If you see here the question is given to solve the value, that is 1 minus x square y n plus 2 minus 2n plus 1 into y n plus 1 minus n square plus m square y n is equals to 0. That is what we got the value in the last step. Now one more question is given, that is y is equals to sine inverse x whole square. Y is given to us, then prove that 1 minus x square y n plus 2 minus 2n plus 1 x y n plus 1 minus n square yn will be equal to 0. So by the help of y we have to prove this value. Y is given sine inverse of x whole square. Now we will do the derivative. So after doing derivative, here it is given, if you see here, derivative of sine inverse x whole square, so 2 sine inverse x, but again here we have to follow the chain rule, so sine inverse x derivative will be 1 by root over 1 minus x square. So this value will get multiplied to the left hand side and will be written as y1 root over 1 minus x square is equals to 2 sine inverse of x. Then in this step also we will, to remove the root value, we just multiply, what we say, we will apply the square value. So squaring both sides, you will get the value as y1 whole square, y1 whole square, then multiply of 1 minus x square is equals to, so on squaring this you will get the value as 4. Again sine inverse of x whole square. So it is given in the question y is equals to sine inverse of x whole square. That's what I have considered this value as y. Now again we will do the derivative for this function. On derivating, as we have taken by using the product law, we will solve this one and we get the value as, see here, we will get the value as 1 minus x square. That means here I have followed the product rule only. On solving, means the derivative of 1 minus x square will be 2 minus 2x, and the derivative of y1 whole square is nothing but 2y1, again y2, derivative of y1 will be y2. So this is what I have written. 4 is a constant value, derivative of y will be y1. So on arranging this equation, we got 1 minus x square into 2y1 y2 minus 2x y1 whole square is equals to 4y1. Now here also we will divide 2y1. So when we divide 2y1, the equation will be 1 minus x square. So this value get cancelled out. Y2 minus, here 2 value will get cancelled out. Here we have 2 y1s. So we got minus x y1 is equals to 2. So for this we will apply the Leibniz theorem. So by applying the Leibniz theorem, so this will be our first function and this will be our second function. When we apply the Leibniz theorem for the first function, here y2 is our recurrence function and the 1 minus x square is our non-recurrence function. So now we will apply the Leibniz theorem here, and similarly we will do x is our non-recurrence function and y1 is our recurrence function. So by applying Leibniz rule we got the value nc0 value is 1. So on derivating this value we got yn plus 2, then multiple of 1 minus x square plus nc1 value is n and the derivative to the n minus 1 will be y2. So y2 and the power is written as 1 minus n. So which is equals to n plus 1. Okay, derivative of 1 minus x square will be minus 2x plus nc2 value is nothing but n into n minus 1 by 2 factorial, and the y2 derivative power is given as n minus 2. So the value remains is yn, and the second derivative of 1 minus x square will be minus 2x. And the same follows for the second equation, that means for the second function. Then here the 2 factorial and 2 will get cancelled out. And on rearranging this equation, I can write it as 1 minus x square yn plus 2, then minus 2x and yn plus 1. Now here minus will get multiplied, so minus n into n minus 1 yn plus x yn plus 1. Again this minus will multiply inside and it will be written as minus n yn is equals to 0. Now taking the common terms, that means if you see here x yn plus 1, and also we have here yes, x yn plus 1. So for that I have taken the x yn plus 1 as a common, then 2n plus 1. If you see, the positive term of nyn, negative term of nyn will get cancelled out and the remaining will be n square yn is equals to 0. So this is what given to prove us. So we have proved the equation by using the given function. You can check it out the value. It was given 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1 minus n square yn is equals to 0 by using the equation called y is equals to sine inverse of x whole square. Now the last question of this topic is given that y is equals to sine inverse, y is equals to sine of m sine inverse of x. So this is the y value given to us to prove the particular this equation. So let me consider y is equals to sine m sine inverse of x. So when we do the derivative, consider this m sine inverse of x as x. So if you see, sine x value means the derivative of sine x will be cos x. So now we will follow the chain rule. When we apply the chain rule for this value, m sine inverse x, m is a constant value and the derivative for sine inverse x will be 1 by root over 1 minus x square. So this value will get multiplied to the other side and it will be written as y1 root over 1 minus x square is equals to m cos m sine inverse of x. So to remove the root value, we will do square on both sides, squaring both sides. Okay, on squaring both sides, it will be written as y1 whole square into 1 minus x square is equals to m square cos m sine inverse of x whole square. Then this square gets multiplied here and we know cos square x plus sine square x is equals to 1. So here the same formula has applied, is equals to 1, then cos square x is equals to 1 minus sine square x. So for cos square I have written 1 minus sine square m sine inverse x. Then in the question it is given the y value as, if you see the values, y is equals to sine m sine inverse of x. So here it is given sine square m sine inverse x. So I have taken the value as y square. So this will be our first equation. By using this equation, we will do the derivative and we will get the proved value. So when we do the derivation of this, so this will act as a u value and this is also our v value by using the product rule. Okay, by using product rule, I have solved this equation. Then I got y1 whole square. Derivative of this v is nothing but minus 2x plus v, derivative of this value. So derivative of y1 whole square, which is nothing but 2y1, and the derivative of y1 is y2. So this is what I have written, and m square is our value, and derivative for 1 minus y square is written as minus 2y and y1. Okay, so this is I have written. Then on multiplying you can get the value like this. So arrange the equation as 1 minus x square into 2y1 y2 minus 2x y1 whole square is equals to 2 is equals to minus 2 m square y1. Now simply we will divide 2y1 in this equation. So on dividing you will get 1 minus x square y2 minus x y1 is equals to minus m square y. So this will get changed to the right hand side, left hand side, and this negative term will change to positive 1. Now here we have three functions. So this is our first and this will be our second function and this is considered to be as third function. And in the first function y2 is our recurrence function, 1 minus x square is our non-recurrence function. Similarly in the second part y1 is our recurrence function, y2 will be our non-recurrence function. And here m square is a constant value, y will act as a recurrence function. So here we will apply the Leibniz rule. On applying Leibniz rule we get the value like this, somewhat like this. After writing, let me solve. nc0 value is 1 and the derivative for y2, as I have told you, y2 and the power is n, so I can write it as yn plus 2, then multiple of 1 minus x square. nc1 value is n, so derivative here it is given y2 and the power is given n minus 1, so this will be n plus 1. Okay, then the derivative of 1 minus x square will be minus 2x, and nc2 value as I've written n into n minus 1 by 2 factorial, and so on. After that means after substituting the values, this is what we will get. Now by rearranging this equation, we will get 1 minus x square y n plus 2. Then here minus 2x n y n plus 1. And here 2 factorial and 2 will get cancelled out. And this minus will multiply in the that means in the bracket. So it will be written as minus n into n minus 1 yn. And here this minus will multiply in the bracket and it is written as minus x y n plus 1 minus n y n plus m square and yn is equals to 0. So here also we have a common term x y n plus 1. Here also we have x y n plus 1. On taking common, the next equation will be written as 1 minus x square y n plus 2 minus, as we have taken the value what we have taken y n plus 1 from this side, and also we have here y n plus 1 into x. So on taking common, I wrote the equation as x y n plus 1 2 n plus 1. Then I just multiplied the values here. So minus n square and y gets multiplied and then again n yn. So minus minus will be plus. Okay, then minus n yn plus m square yn is equals to 0. Here the positive term of n(yn) and the negative term of minus n(yn) will cancel out, and the remaining, if you see these two values, we have a common term called yn. So by taking yn as common, this will be written as m square minus n square. So this is the answer which we have solved by using the given equation, which is y is equals to sine m sine inverse of x, and this has given to prove us. So this is what we have the answer also. So that's it for today, and in the next class we will start concavity and inflection point. Thank you.